Alright, so in this video we have a continuation of some of the basic problems that you find in the college algebra class. And the one I want to address first are the ones that, at least on the My Math Lab assignments, they look like this. They say, if we give you an equation like x plus y is 35, is y a function of x in that equation? Okay, and so there you'll see a problem like that, and then later on you find one like this. Same thing, you get an equation, x squared plus y squared is 144. Is y a function of x? Okay, now in the first video I ever made for our class, I told you what that means. If y is a function of x, that means that we pair x and y together. And you might say, what's x and y? Well, I don't know. I mean, does it make sense to pair things together? Like, I could make a chart of the time of day and where you are at that time of day. You can pair those things together. So, sure, you can pair things together if you want to, all day long. But if y is a function of x, that means that every x is paired with exactly one y, okay? Why exactly one y? Well, because if we use my example of pairing the time of day with your location, it wouldn't make sense for one time to get paired with two locations. It just defies common sense in almost every case, all right? So if you want the whole philosophical reason for why a function is that way, then that's basically what it is, okay? All right, now let's go to this problem here and say, you get this equation right there, is y a function of x? Okay, so here in red, I'm reminding you what that means. It says, does each x get paired with exactly one y? What x's and y's even get paired together there? All right, so I'm going to give you some examples just so you can see what I mean. Okay, now I'm coming up with these numbers. I just want to see if you agree with me. All right. Suppose that x was 1. And remember, when we write our pairs, x comes before y, just like in the alphabet. So suppose x was 1. What would y have to be to satisfy that equation? It had to be 34, right? Right. What's 1 plus 34? That's 35. Are these numbers, if that's the x and if that's the y, are they justifiably paired together? Sure. Okay. Do you see in that equation any way that an x could get paired with 2 y's or 3 y's? I mean, we could do this all day. What if x is 0? What's the y got to be? Think about it. 35. All right, so here's 1x getting paired with exactly 1y. Do you see any way that if I just choose whatever number you want for x, is there any way that there could be two choices of y that are going to work out of that? No way. I mean, in this equation, every x that you could ever think of gets paired with exactly one y. And so we'll say, sure, it's a function. If you ask me yes or no, is y a function of x? I'd say yes, y is a function of x. And for brevity, we just say it's a function. All right. Okay, now let's take a look at this one. A different equation, same question. Is y a function of x? Well, so I'll take the same approach. All right. I know I could give you shortcuts and all that kind of stuff, but you won't learn anything. So I'm not gonna just tell you some shortcut or something like that. Let's try to think about like this one. If I were to choose an x, and just choose one, like whatever number you think is easy. Could we like prove or disprove somehow that say every x gets paired with exactly one y, not 2, not 3? Or could we disprove that? So I'm going to do this. I'm going to say, all right, examples. Here's some numbers that could work there. What if x was 0? Okay, 0 is a nice simple number. So I'm going to say, all right, how about this? I'm going to put 0 in here, and I'm going to try to figure out what the y is supposed to be, just like I did up there. So I say, okay, put 0 in. 0 squared plus y squared equals 144. Okay, and I'll try to tell you what the y is. What's 0 squared? Well, that's 0. What does it say? Y squared is 144. Okay. Now, how do we solve for the y? Figure out what that's supposed to be. How do you solve for the square? What do you think you do to solve that square out of that equation and get an answer? Most people, if you're watching this right now, you're going to tell me take the square root of that number. And if you tell me that, then you're halfway correct. But in math, it's no good to be halfway correct. So what we do is when we solve for a square, we take plus or minus. And I'll give you a way you can remember that, all right? Okay, so let's do this. Say we get y is equal to either plus or minus, and the square root of 144 happens to be 12. I get two answers. I get 12. I get negative 12. Does it work? What's 12 times 12? Let's try it. What's 12 times 12? 12 times 12. 44. Isn't that what squaring means? Y squared? Y is 12? Okay. 12 times 12. What's negative 12 times negative 12? Oh, so they both work, you see? That's why when you solve for squared, the plus works, but the minus is going to work too, I guarantee it. A negative times a negative is a positive. 12 times 12 is 144. Negative 12 times negative 12 is still 144. So it looks like this. It looks like 0 gets paired with 12. Because, in that equation, you can have x be 0 and you can have y be 12. They go together. And I guess you could also say that if x is 0, y could be negative. That would work too. 0 squared plus negative 12 squared, 144. It satisfies the equation. These two numbers go together. All right. Okay, so to answer the question, is y a function of x? What would that mean? It would mean that each x gets paired with exactly one y. Well, that does not happen here. X being 0 gets paired, however you want to write it. You can see it up there if you want to, but you can say, look, it gets paired with two y's. All right? So is y a function of x? The answer to my question is I'll just say no. All right? Okay. Now we could if you want to, if you don't want to think about it all philosophically, I think if you're learning some math, you should learn how to really think about some math. That's the whole point. But I guess you could say if the y was squared, this plus or minus thing would always happen, and you'd get the two y's, and it wouldn't be a function. I guess you could say that if you wanted to. All right. Okay. All right. So we're done with those. Let's put that aside. Now, next thing is let's say that we know we have a function. We know that we have an equation where if you plug in an x, you get exactly one y. All right. Then when we are in that situation, we write this stuff called function notation, and you see that deal right there that says f of x. I guess you could think of that as like it sort of like that there's the y there. All right. All a function is something that pairs x's and y's together. All a function is something that pairs two different things together. Time of day, location, anything you want. You can convert miles to kilometers. There's a function that does that conversion. It pairs the numbers together. Now, we write the function notation because it as we do more and more advanced math and science, there's an advantage to writing this. It says f of x All right, that's how we read that. And when we write that down, we do things like this. We say, what's f of negative 3? And all that's saying is, what would the y turn out to be if you were to plug in negative 3 for the x? It's just an easy way to ask that question. If I didn't have function notation, then I'd have to actually write out, tell me what y is if I plug in negative 3 for x. Do you see how this is just kind of a shorthand for that? It's just an easy way for me to say, what do you get out if you put that number in? So that's the reason why we write function notation. All right. Okay, now so, well, where do you think you put the negative 3? I mean, I'm telling you literally, it just says put this number in for the x in that function. All right, so wouldn't it look like this? 5 times negative 3, take away 3. And what would that be with 5 times negative 3? It's negative 15. Okay, because we multiply and then we'll subtract, we'll get negative 18. Okay. All right, so that was not too bad. If you put negative 3 for x, you get negative 18 for y. All right. Now, where people can accept that fairly easily when they take algebra, they'll have a harder time doing something like, what's f of x plus 1? All right. It's like the x's here, and there get confusing, or they get them mixed up. All right. So I want to tell you a way to think about what you see here and what you see here. I guess you could say a function is a way that you pair two things together. But I could also say that it's just like inputs and outputs. All right. This function is such that if you put negative 3 in and you do the math, then you get negative 18 back out. If you want to call x the input and y the output, then go for it. All right. Now, because that's not a number, and you might think it's crazy to not put a number into a function, but in math and science, we need to do stuff like that sometimes. I might do like this. I might say, look, the x right there in this function, all it does is indicate where the input goes. Okay, so see how I rewrote it? And I just, instead of putting an x so that we don't get it confused with this x, I'll just say, look, here's the way this function works. It's 5 times whatever the input is, take away 3. All right? Now, so say you want to do this, and you look at that like, all right, that deal right there, x plus 1, that's the input. That's what goes in the function. And where do you put the input to the function? You put it in that spot. This x being here originally is just indicating where the input goes. All right? So take that, look at it that way, and say, all right, here's what that would become if this was the input into that function. It'd be 5. Where does it go? Right there? Okay, so input is x plus 1, take away 3. Okay? So do you see how these look alike? But I put the input where it's supposed to go. All right, the x in the function originally indicates where the input goes. All right, so I did that, and everything is written down correctly there. In math, though, we might get the first step right, but we try to see if we take it a little further. And can we do anything with this? Can we combine some of the numbers and so on? Well, there's a way to multiply that. It's called the distributive property. And it says, well, everything in that parentheses gets multiplied by the 5. So we'll say 5 times x plus 5 times 1. And then we got to subtract 3 right there. So at that point, I realized I can combine a 5 and a minus 3. So I'll get 5x. What's that going to be? Plus 2. All right. There we go. Now you could take whatever variation of this you want. What do you think about this one? What's f of negative x? I mean, it's the same story, right? You could even, if you want to, you could pause the video and you can see if you try to do that one based on how I explain this one. But, you know, I got that function. See this deal? 5 times the input take away 3. Well, that's going to be the input. All right? So let's see. 5 times the input, which is negative x this time, take away 3. Can I do anything with that? What's 5 times negative x? That's a positive times a negative. All right, it's like 5 times negative 1 times x. It's going to be a negative 5x minus 3. And there you go. Okay. All right. Now, you know, when we learn algebra, it's, I guess, depends on who teaches it to you, what book you use, and all that kind of stuff. But, you know, this function doesn't mean anything. It doesn't really serve any practical purpose. It's just an example. But it's, you know, I give you examples all day of functions that serve purposes. I think it would kind of get in the way of learning how to do the math, but I'll show you real quick an example. Like here's a real function that we can use to do something, okay? Say you want a function to convert Celsius temperatures to Fahrenheit temperatures. You know, you can measure the temperature however you want to. Where we live, we do things in Fahrenheit, and many other places they use Celsius. But it's all temperature. I mean, it doesn't really matter how you measure it. The temperature is what it is, okay? It's kind of like I can say, I got 12 inches or I got a foot or something like that. So here's the function that where you plug in the Celsius temperature. Why do I say it like that? Well, because, you know, kind of look at how this one's written. You know, that's the input. And I'm going to get out the Fahrenheit temperature. That's how that's supposed to work. All right, so there's your real function then. All right, if you want a real example. And it says, well, what Fahrenheit temperature is 5 degrees Celsius? How is this function supposed to be used? You plug in the Celsius temperature here, and what you will get back out is the Fahrenheit. So we'll see what's it mean in Fahrenheit if you have 5 degrees Celsius. It shouldn't be too hard. So let's say in the function I plug in the number 5. The number 5 represents the Celsius temperature. The input of this function goes right there, okay? And I get like so. And now I got to do my calculation. Let's see, 9/5 times 5. Well, that's like a 5 over a 1. The 5's cancel. You could also think of it as I multiply fractions straight across, and that's a 5 over 1, so it's 45 over 5, which is 9. And we'll get 9 plus 32. Or we'll get 41. Okay? You can go look it up. You can go, I guess, you want to type in the internet, what's the Fahrenheit temperature for 5 degrees Celsius? 41 degrees Fahrenheit. Okay. All right. So I wanted to give you that one as just, you know, something realistic to follow this up. All right. Okay. Let's do one more thing. Now, you'll find probably towards the end of the first assignment, something like this. It'll say simplify that for this particular function or a function like that. And this thing is called the difference quotient. Okay. And what's that do? Well, it's basically if you take more math or take more science, we use something like this to measure the instantaneous speed of a moving object, okay? If we have equations that describe its motion. And you might say, well, I'm never going to take physics class, so whatever. Well, but you're in algebra, And this is part of it, so here we go. We're going to learn to do it. Now, it looks like there's three things to do. You got the h, which, what could you possibly do with that? It's just h. It's just a variable. And then you got f of x, where what's that? That's the name of this function. So like this, no big deal. This, no big deal. The minus, okay, a minus. The only thing about this to be careful with is that f of x plus h. But we talked about something kind of like that before, You just a minute ago, you say, I got this function. That's where the input goes, and I can put anything into that function I want to. So, all right, there's the function. If you really want to, if it helps you, you can say, all right, I know that all the x signifies is where the input goes. So I just leave it as like an empty square if I want to. Okay? And I'm not worried about this. I'm not worried about this. I'm just worried about that one. So I'm going to do that first. I'm going to figure out what that is. So what if you took this function and you put x plus h as what? As the input. Okay? And where's the input go? The input goes right there. Right? That's what this x signifies, where the input goes. So we'll say, here's what this is going to look like. It's going to be 5 times x plus h squared. Okay? All right. Now, I would need to simplify that if I can. If I can do anything to it, I will. And what do you do first? Do you multiply by 5 or do you square? What's the order of operations? The order of operations is to square. It's the exponent. And what does it mean to square something? To square something means to multiply by itself. So there you have it, and multiply by itself. And how do you multiply these two things by themselves? Well, if I multiply two things together that each have two terms each, there's something called FOIL multiplication. I multiply the first terms, x times x. That would give me x squared. I multiply the outside terms, x times h. I multiply the inside terms, h times x. That's the same thing as x times h, so we'll just write it the same way. Isn't 2 times 3 the same as 3 times 2? Sure. Let's just write them the same way, though, and make it look easier. And out, h times h is h squared. So I don't mind reviewing if you're not so sure about FOIL multiplication, but that's what it is. We can review it. All you gotta do is ask. Anyway, so what's that gonna be? Can we combine any of this stuff? Aren't those the same? xh plus xh? What if you take something and you add another one of the same thing? Doesn't that make 2? What's the one apple plus another apple? That would make 2 apples. Those are the same. So we're going to get x squared plus 2xh, because there are 2 of them, plus h squared. None of these other terms are alike and can be added together. Okay? All right, one last thing. Multiply all the way through. 5x squared plus, what's 5 times 2? 10xh. 5 times 2 being 10, plus 5h squared. Okay, so I did all that just to figure out what this one little piece was up there. Now, it does happen in math. It's complicated. You can do one little piece of the problem and forget that there's this entire other thing you're trying to do. So how about this? I got the h, I got that, and now I figured this out. So I'm going to put it all together, and I'm going to simplify it, reduce it as much as possible. So how about this? This thing that I was given, okay, which you see up there, I can now say about that will be f of x plus h is this 5x squared plus 10xh plus 5h squared. All right, got to take care of that. Minus f of x, which is this given function. See them? Same thing, 5x squared over h. All right, and I got it all right there. Now it says in the problem, simplify it. Does anything reduce out of that? Anything jump out at you? Before I tell you, do you notice it? What's anything minus itself? This makes a 0. Those are gone. Okay, so one step at a time. I'm left with 10xh plus 5h squared over h. Okay. And then let's look at it like this. If I have like one thing down here and 2 up there, the thinking is that everything up there, each term gets divided by this. Well, you can look at that is, you could say, well, what we have is we're going to divide those, and then we're going to divide these. How do I know that that's actually the right way to look at it? Like if I have to remember all this math and all the rules, and I got to remember when you can do what and so on, how do I know that's right? Well, how do you add fractions with a common denominator? You add the tops. Can you get from here to here? You can. So can you go the other way? Sure. What happens? Cancel. H over h. What's h squared over h? Cancel, leave me an h. So I got final, totally reduced, can't possibly do anything else, thank goodness. 10x plus 5h. All right. And there we have simplified it as much as we possibly can. All right, anyway, so do my math lab assignment. Watch the video, pause it, ask questions, do whatever you have to do, but good luck on the assignment. Thanks.